Hello everyone, I'm Miss Sahara. Today we're going to go through the integration techniques and do some practices. First is the definition. Integration is the reverse process of differentiation. And there will be two paths of this tutorial will be indefinite integral and definite integral. So what is an indefinite integral? The indefinite integral of fx with respect to x. You integrate fx equals fx plus c, where fx is the integrand and c is the constant of integration. C could be any numbers. And continue. There will be the two properties of indefinite integral. You can see the first property is integrate k fx dx will be k times the integration of fx. We can move this k. K is the coefficient before this function. So we can move this k to the front. For example, this is a 5 over 4x minus 3. This actually is 5 times 1 over 4x minus 3. So we can move this coefficient to the front. So equals 5 times integrate 1 over 4x minus 3. And then you're going to get confused. How this 1 over 4x minus 3, the integral is low and something. Later, we're going to learn the basic techniques too, and then you understand. Don't worry. Next property will be if we integrate different functions, you can integrate them separately. So for example, you integrate the afx plus minus bfx dx. You can integrate them separately. Don't forget to move this coefficient to the front. It will be easier. So we integrate them a times integrate fx dx plus minus b integrate fx dx, where a, b are constants. For example, we can see one example. You integrate 2x to the power 3 plus 5 to the power 2 dx. So how to integrate them? First, you need to remember that in our integration, there will be no product rule or quotient rule. So once you see this is the 2x to the power 3 plus 5, the first way you need to think is to break the bracket. So here, look at that. We expand this bracket. We use the distributive law, and then we can try whether we can get this result. So 2x to the power 3 times 2x to the power 3 equals 4x to the power 6. And 2x to the power 3 times 5 will be 10x to the power 3. Plus 5 times 2x to the power 3 is another 10x to the power 3. So we have two 10x to the power 3. You add them together, you get 20x to the power 3. And next term will be the 25. 5 times 5 is 25. Done. And later, we integrate them separately. From this property, we can integrate these functions separately, and then we can get this result. How we get this result? Don't worry. We're going to learn the techniques, and then you will understand. The first is the basic techniques formula booklet. Here is the integral. If you integrate k, a constant, you will get kx plus c. For example, if you integrate 6, you're going to get 6x plus c. And next, you integrate x to the power n. And then the integral will be x to the power n plus 1 over n plus 1. So how to memorize? Very easy. Just the power plus 1 over the power plus 1. So here, this is integrate 4x squared dx. First, we move the coefficient to the front. And then this is x to the power 2. X to the power 2 will be the power plus 1 and over the power plus 1. So the 4 times x to the power 3 over 3 plus c. Don't forget plus c because they are the indefinite integrals. And next, you integrate ex will be ex, the same. For example, if we integrate 8 ex dx, we can move the 8 to the front. So it will be a ex dx. Next, integrate 1 over x dx will be ln x. Don't forget the absolute value sign, okay? It's very important. So let's see one example. There will be the integrate 5 over x. 5 over x is 5 times 1 over x. So we can move the 5, this coefficient to the front. This is from property 1, right? This property, move the coefficient to the front. And next, we integrate the 1 over x. We can easily get ln x. Next, Integrate cosine x, you can get sine x. Integrate sine x, you can get negative cosine x. Oh, maybe some students will be very confused. This because in the differentiation, it is the opposite process of differentiation. So students will confuse when to add negative. It's very easy. You can double check, use your integration because you are very familiar with the formulas in differentiation. So we can use the differentiation check. If you differentiate sine x, what are you gonna get? It is sine x prime. You can easily get cosine x, right? So that's why if you integrate cosine x, you can get sine x. Understand? And continue. If we differentiate, we can check, okay, use the opposite operation to check. If you integrate, if you differentiate the negative cosine, you can get sine, right? You can get sine x. Okay, so this is the way for you to memorize when you're going to add negative, when you don't need to add negative. Don't forget to double check, it's very important. Okay, next. So let's see the example. This is the integrate cosine x over 7. So it's 1 over 7, right? We can move this 1 over 7 to the front. And when you integrate cosine x, you can get sine x. Okay, you can also double check. For example, if you differentiate sine x, you can get cosine x, right? Differentiate sine x, you can get cosine x. Okay, cosine x. Yes, we are right. Next, if you integrate 7 sine x, you can get negative cosine x. So the 7, you can move to the front. Okay, no problem. Use the formula. Next, we have know the c. Then how can we find c? How can we find c? It will be to find the particular values. Okay, there will be 2 steps. First, you do the integration. Just follow these formulas. Okay, and do the integration. Second, you plug in the given value to find the c. Okay, what do I mean? Let's see an example. The integration, the differentiation fx equals this equation, and then we have this particular value, and we need to find fx. So how to get fx? Very easy. First, fx equals the integral of this expression, right? And there are so many functions. We can integrate them separately from our property, right? We can integrate them separately. So you integrate 3x to the power 3, you can get what? Very easy. If you integrate 3x to the power 3, and then you can get 3 times x to the power 4 over 4, right? The power plus 1 over the power plus 1. And this is 5. 5 keep the same. Coefficient keep the same. And then the x to the power 2 over 2 plus 1, so it will be 3. 3 over 3. So 5x to the power 3 over 3. Next, it will be 8. This is, don't forget, this is x to the power 1, understand? Ax is actually 8x to the power 1. So the 1 can be add 1 to the power. So ax to the power 2 over 2. The power plus 1 over the power plus 1, don't forget it. And minus 2x, because we said if it is a constant, you just add x, right? From a formula. Don't forget this formula. If it is a constant, you just add x. Okay, so minus 2x plus c. Don't forget to plus c. As long as there's no this integral sign, you don't forget to add c. Okay, don't forget to add c. So we simplify. This is a over 2. A over 2 will be 4. Okay, so this is a 4x to the power 2 minus 2x plus c. Done. Next, we have the particular value, right? This is when x equals 2, the fx will be, when x equals 0, the fx will be 2. So let's see. We can substitute this special value. F0 equals 2. For example, we can label F0 right here, and then equals what? Equals, substitute x equals 0. So it will be 3 times 0 to the power 4 over 4. Any number times 0 still will be 0. So this is 0. Minus 5 times 0 to the power 3 over 3 still 0. Any number times 0 still 0. So plus 4 times 0 still 0. And then minus 2 times 0 still 0. And then plus c. Plus c equals what? Equals 2. Because f0 equals 2. So c equals 2, right? It's easy. C equals 2. Thus, fx equals 3x to the power 4 over 4 minus 5 times x to the power 3 over 3 plus 4x to the power 2 minus 2x plus 2. Don't forget to replace c with 2. Okay, so we finish our techniques 1. And then let's go through some questions.